Have you ever watched a movie where a fighter jet, with a missile hot on its tail, suddenly releases a burst of bright, fiery objects and miraculously escapes? That's not just Hollywood magic. That's a real-life defense system called flares. And it has a less flashy but equally important counterpart called chaff. So what are these things, and how do they actually save pilots' lives? Let's start with flares. Think of them as super hot, high-tech decoys. A modern heat-seeking missile, also known as an infrared-guided missile, is designed to lock onto the intense heat coming from a jet's engine exhaust. To fool it, a pilot can deploy flares. These are small cartridges packed with a special pyrotechnic material, often magnesium-based, that burns at incredibly high temperatures, even hotter than the jet's engine. When released, they create a brilliant, fiery bloom. The missile seeker, programmed to go for the hottest thing it can see, gets confused. It now has multiple hot targets to choose from, and it will often divert its course towards one of the flares, giving the pilot a precious few seconds to change direction and speed away to safety. You've probably seen this in action without even realizing it. The iconic A-10 Warthog, famous for its close air support role, often carries a large number of flares because it flies low and slow, making it a prime target. During the Gulf War, A-10s used flares extensively to defeat Iraqi heat-seeking missiles. It's a dramatic and effective defense that has been a staple of air combat for decades. Now, let's talk about the other half of the duo, chaff. Chaff is designed to counter a different type of threat, radar-guided missiles. Unlike heat seekers, these missiles use radar waves to find and track their target. They send out a pulse of energy and listen for the echo that bounces back off the aircraft. Chaff is the ultimate radar jammer. It consists of tiny, hair-thin strips of aluminum or metallic glass fibers. When a pilot deploys chaff, a canister ejects these strips into the air, where they disperse and form a large, dense cloud. To the enemy radar, this cloud of metallic fibers looks like a massive, solid object, much bigger and more reflective than the actual aircraft. The radar gets overwhelmed by this huge, confusing signal. The missile's guidance system can no longer distinguish the real jet from the giant cloud of chaff. It might lock onto the cloud instead, or it might just lose its lock altogether. This momentary confusion is all the pilot needs to perform an evasive maneuver and escape the radar's detection. A classic example is the B-52 Stratofortress bomber. These giants have relied on chaff for decades to create a screen of radar-jamming material, helping them penetrate enemy airspace. So, who uses these countermeasures today? Pretty much every modern military aircraft, from fighters and bombers to helicopters and transport planes. Think of the F-22 Raptor, the F-35 Lightning II, the Eurofighter Typhoon, or the Russian Su-57. They all have sophisticated, integrated countermeasure systems. These aren't just simple dispensers anymore. They're smart systems tied into the aircraft's threat warning receivers. When the plane's sensors detect an incoming missile, the system can automatically identify the type of threat, infrared or radar, and deploy the appropriate countermeasure, either flares or chaff, sometimes even before the pilot has time to react. In modern systems, the deployment can be incredibly precise, creating specific patterns designed to maximize the chances of fooling the latest generation of smart missiles. Some aircraft even use new types of decoys, like towed decoys that trail behind the plane on a wire, broadcasting signals to lure missiles even further away. So, the next time you see a jet light up the sky with a brilliant shower of sparks, you'll know it's not just for show. It's a life-saving dance of physics and engineering, a high-stakes game of cat and mouse played at supersonic speeds. Flares and chaff are simple in concept, but they have been, and continue to be, absolutely essential for keeping pilots and their aircraft safe in the world's most dangerous skies. Thanks for watching. If you enjoyed learning about this amazing technology, be sure to hit that like button and subscribe for more deep dives into the world of military hardware.